Today on Janky Just Does Stuff, going to be making a 3/8 inch chisel commissioned by a friend of mine. Just heating up the forge here, getting it blowing. Here we go. I'm about to speed it up a whole bunch so you don't have to watch the whole process, but you get a feel for how it looks. The steel I'll be using to make this chisel is called 1084. It is a simple carbon tool steel with 0.84% carbon and 0.5% of manganese or so. This is considered a eutectoid steel, so it's a bit more forgiving of cruder heat treat methods while still providing a full conversion of hard martensite when treated nicely. The cycles of heating the steel back up, banging on it, and returning it to the fire are called heats, the first of which is happening now in normal speed to give you a sense of the flow of time here. You start off with very hot heats to keep the steel soft, during which the bulk of work is done, and then progressively moving to colder heats that allow finer, more precise work. You'll see that I've put some water on the face of the anvil here, which is an old Japanese swordsmith trick. The steel is so hot that it doesn't immediately touch the liquid water, forming instead a vapor jacket in a process called the Leidenfrost effect. When you bang the steel into the anvil, you collapse that jacket and the water boils explosively, blasting off the forge scale, aka magnetite, aka oxidized iron that forms on the surface of the steel in the forge. This basically just keeps the thing a little bit cleaner, prevents you from having to get it out later as it gets banged into the work itself. Again, like in swordsmithing, constant checking of dimensions is vital. I use a pair of calipers, a small ruler, and a yardstick to check various dimensions of the work throughout the process. Forging is a transformative process, allowing stretching and squishing of the material to the size and shape required, but some transformations are a real pita to undo. A dip or a dish on the surface of a work is extremely troublesome and has to be ground out later. Any work done now saves considerably more effort down the line. What you see me doing here is a process called drawing out the steel. I'm using the face of the hammer to squish away the steel in all radial directions, flipping it over, and then pushing back in the side effects of the previous hammer blows. Blacksmithing is like a dance, kind of. You take 2 steps forward and 1 step back with any action. You can see how I'm making the bar flatter and wider, and then I have to straighten it back out and make it thinner again. Forging induces stresses into the steel, making it behave badly down the line if you aren't careful. The forging needs to be done evenly on all 4 sides to ensure that the residual stresses are kept to a minimum. This also prevents warps and twists especially that are a challenge to undo. You see again me checking the dimensions, making sure the thing is straight. I'm going for a gentle, shallow taper from the end to end. Now that I have the basic shape of the chisel portion mostly complete, I move to the back half of the thing, thinning down the steel in preparation to make the decorative neck and tang section of the chisel. This can be done pretty roughly. A lot of the further refinement will come later after the hot cut. Just a few more finishing touches on the steel, and it's time for cutting. I use my Hardy tool, which is that little chisel-shaped thing, to cut the thing off like a pair of scissors. You just sort of bang it in the top, and it cuts it right off. You can see that I've done that here. It's not a gorgeous cut, but it certainly does the job. Back into the fire. The tang is the section of the chisel blade that gets forced into the handle. It serves as a place for the wood, and therefore you, to hold on to it. You can see the taper forming rather quickly. You want the thing to be fairly narrow so that it's easy to force into the handle, but thick enough to where it's strong and is not likely to snap or bend in use. Once I'm done with the finishing touches, plop it down, let it cool to start the grinding process. First, I use the disc sander to square up the surfaces crudely. Not too much to see here, just making sure the thing's dead square. Next comes the real star of the show, the belt sander, or blacksmiths call them belt grinders, despite the fact that they are technically sanders. This thing is where 90% of the magic happens. I take the squared surfaces that I got from the disc sander and work them till they're actually flat. This is a 60 grit ceramic belt that I got from Combat Abrasives, which I quite like, actually. Technical order here isn't super important, but I'm taking some steps to flatten the tip to where it's squared off as well, and start to refine that decorative neck that I sort of pounded in before, make it a little bit smoother. No matter how good you are with the hammer, there's always more work to be done with the grinder. I chuck the chisel up into a bench vise, and then use a mill bastard file half round to continue refining the shape of the decorative neck, and finishing up the transitions between the main chisel body and head. The file is a much maligned piece of equipment, and I feel like it hardly deserves such a reputation. The trick to using one is to always only use a push stroke. The teeth of a file can be bent over and dulled by the backstroke, rendering it almost immediately useless, but in for anything but the finest work. Once I'm done with that, take it back to the belt sander. I've now upgraded the belt to a 120 grit belt, which actually, in the form of the belt sander, produces a pretty decent finish. Here I've slowed down the footage so I can show you what it looked like as I was working on it at this stage. It's got a nice matte finish, all the lines are square, and generally things are in the place that they should be. It is at this point, it is time to go to heat treatment. This is a process called quenching, through which we harden steel. It is known as yakiire in the Japanese sword world. It is without a doubt the most terrifying, heartbreak-filled part of the process. I've omitted the normalizing footage, but the blade must be heated past critical and air-cooled a number of times to reduce grain size and de-stress the steel. Warps that form from relaxation have to be corrected now or never. During hardening, the blade itself is heated again to critical and plunged into water, as you just saw, to rapidly cool and convert the steel to martensite. The internal stresses at this moment are staggering, and a decent portion of blades do not survive, cracking or snapping in half outright. Luckily, it does not seem to be the case this time. The blade is immediately returned to the forge for just a moment to heat it up to about 400 Fahrenheit, thereabouts, to take some of the stresses right out of the front of the steel. After a bit more inspection to make sure that there are no cracks, back to the grinder. The second half of this process here is finish grinding. It is another great place for you to ruin your work and lose a lot of time. Now that the steel is heat treated, it has to be kept cool to prevent the steel from softening. Grind for just a second, swish it around in water and repeat. It's tedious, but it's absolutely necessary. I'm working with a 220 aluminum oxide belt here. I am now putting the first bare hint of an edge on this chisel. It's not going to be very sharp, but grinding it slowly is absolutely critical, yet again. Time to switch out belts for my 320. The process is then repeated yet again. This sort of iterative cycle of continually finer and finer grinding allows you to approach the final surfaces and get a better and better finish. Switch too early and you'll regret it. Make sure that every grind line from the previous grit has been ground out completely before you advance to the next. I should apologize for the sound here. I'm listening to a podcast because my headphones died. It makes a kind of funny sound when it's sped up. I don't have a ton of advice for you here other than practice. It sucks, but you do get used to it. I'm now going to show you again the slowed down footage of this next stage. This is a 220 grit grind. So you can see things are shaping up quite nicely at this point, and it's about time to move on. This is a King Waterstone 300 grit. I'm using it to apply the actual bevel of the chisel set at the angle I want with this chisel grinding guide. This Waterstone is amazing for rough grinding. I'm a huge fan of Japanese Waterstones of basically all kinds, and I have a embarrassing amount of money invested into them as well. They are wonderful, and there's absolutely no replacement for them. Except for maybe these diamond plates. You can achieve a really nice, quick grind with these things. This one has a combo of 400 and 1000 grits on it. Extremely useful. Once the bevel's refined, I go back to doing the rest of the geometry of the chisel in the various different sections on the 300, followed by a 1000, followed by a 6000, and then some additional work done with a stropping pad that I have. This delicate work I'm doing right now is basically just ensuring that all of my lines are straight and everything is visually appealing at this point. It's way too late in the game to be making major structural changes. If you've gone this far without fixing a bend or warp, you're toast. Here's a 6000 grit grind. Still kinda matte. And of course, cleaning is part of the process. Flatten your stones, work them, put them away. Here's after a bit more stropping that I did not include in showing the footage. Just very final touches with a green rouge embedded leather pad, and that should just about do it. I actually really ran out of time on this project. I intended to finish the chisel handle up quite nicely, but as I was supposed to give it to the guy today, I had to work quickly, so you don't see any of that process happening, and I'll be counting on him to send me some photos of it later. In the meantime, last step, do some tempering of the steel at 420 degrees to give it this lovely hay yellow tone and soften the steel back down from the Rockwell hardness that it was before, 60 plus. This gives me enough strength in the steel to where it looks the way you want it to, behaves the way you want it to, and is at considerably less risk of snapping off in your hand. I also like the color. That wraps it up for today. Thanks for watching. Till next time.